right, everyone, here we are with lesson 3. Hope 1 and 2 went okay. We are going to start getting into more trig. This is information you've not seen before, so this is going to be very important that you stick with me till the end, okay? Do the best you can, and again, come to my optional office hours if you have any questions. So we're going to start with something called angles in standard form, okay? An angle on the coordinate plane in the standard form when the vertex is on the origin and one ray lies on the positive x side. So I'm going to talk about that. So a ray on the x-axis is called the initial side. So we're going to say this initial side. I keep writing with my numbers together. Let's write that a little bit better. Initial side. Okay? Okay. So your initial side is going to be on this x-axis right here. Okay? This is going to be your initial side. So we're always going to start there. Always. Okay? Then the other ray where you end your angle is going to be called the terminal side. Okay, terminal because that's where it ends. Initial start, terminal end. Okay, so my terminal side will be where you make the angle. Okay, and so we're opening up with that initial side, and then we move to the left and create our angle to end at that terminal side. Okay, this counterclockwise, when you're going to the left, will always result in a positive angle measurement. Okay, so like this angle theta here, this angle could be like a positive, I don't know, let's say 120 degrees. Okay, that's just an example. All right. Now, if you go clockwise, if I go to the right from my initial rotation, I am going to result in a negative angle. So we're going to start looking at negative angles. And it's basically just where the direction of the angle is going. Okay? So now if I take my starting position, but then instead of going to the left counterclockwise and I go to the right, okay, and I end here, we could say like this angle theta here is a negative, let's say 160 degrees. I'm going to show you where these numbers come from in just a moment, okay? So going down is where we're going to get our negative angles, and going up to the left is where we're going to get our positive angles, okay? And then we have revolutions, okay? So if you think of like a bike tire or a car tire making one full revolution, okay? What we have is one full revolution is going to be 360 degrees. So if I make one full revolution here, okay? So if I start on my initial side and I go all the way around, okay? One circle, oh that's funny, is going to make 360 degrees. So we start at 0, we end at 360 degrees. So this 0 degrees is also 360 degrees, and I'm going to explain all of that in just a moment as well, okay? So moving on to the next part, we're going to sketch some angles, okay? And so since we're on a coordinate system, let me show you here. All right. If you think about it, this coordinate system, they are perpendicular lines. The x and the y-axis are perpendicular. So what you have here is 90 degrees. Okay. So if I were to have an angle go from my x-axis, because we always start here, okay, and then go up to the y-axis, that's going to go up to 90 degrees. Oops. Okay. If I go to the next one, it's going to be another 90 degrees. So if I continue my angle and keep going, this is going to be 180 degrees. right? And then if I keep going, another 90 degrees with my angle, I'll be at 270 degrees. And then another 90 degrees with my angle, I'll be at 360 degrees, which is where we started, also at 0 degrees. So this is the same exact angle. 0 degrees and 360 degrees end up being the same exact angle, okay? So from 0 to 90, you're in the first quadrant, 90 to 180, you're in the second quadrant, 180 to 270, you're in the third quadrant, and 270 to 360, you're in the fourth quadrant. So when I come over here to draw my angles, okay, I am going to think about what quadrant am I in. So 75 degrees, I'm going to be in my first quadrant. When I draw my angle, okay, I start with my initial side on the x-axis, and this doesn't have to be exact. You're not getting a protractor out, okay? But obviously, my 75 degree angle is not going to be here because that doesn't seem that close to 90 degrees. Remember, 90 degrees is going to be in this first quadrant, so I'm going to say my 75 degree angle is about here, okay? And so we'll say this angle here is 75 degrees. Okay, and we're done. We're drawing our angle in standard position. Okay, moving on to the next one. Now we have negative 160, so we're going to go in the opposite direction. Okay, so I still start here. I always start with my initial side on that positive x-axis. Okay, and now since we are going to be negative 160 degrees, I'm going to take my angle and I'm going to open it down or clockwise. Okay, so I'm going to go down. I'm going to go down past the 90 and almost up to the negative 180 degrees. Okay, and so this angle here is negative 160 degrees. Okay, so we're going down because it's negative. And the first quadrant was up to negative 90, and the second quadrant going in that direction is up to negative 180. And so I'm just about to hit that negative 180. Okay. And then this last one we have is 430 degrees. Now you can see here we've made a complete revolution because it's more than 360. Sometimes it's nice to see what that the rest of the angle is from that 360. So if I take 430 and I subtract 360 from it, I get 70 degrees. So if you think about this, I've made one full revolution plus another 70 degrees. So let's look at what that looks like. That 70 degrees is called a coterminal angle. We're going to talk about that more in just a second. Okay, so again, we always start from the x-axis. I am making a full 360, and then I'm going another 70 degrees to get to 430. So I'm going a full 360, and then I'm going another 70 degrees, which is in my first quadrant, okay, to get that entire 430 degree angle. Okay, and so this entire angle is 430 degrees. Okay. And those are your angles in standard position. Again, remember the first quadrant is the first 90 degrees. The second quadrant is 90 to 180. Third quadrant, 180 to 270. And then 270 to 360 is in the fourth quadrant, okay? If you have an angle that's 90, 180, 270, 360, it actually ends on that axis, okay? It ends on that X or Y axis, okay? And so that's an angle, what we call in standard position. We're going to look a lot at those, okay? Now we're going to talk about radian measures. Remember I discussed on your calculator you had to make sure you were in degree mode because sometimes your calculator was in radian mode. So now we're going to talk about what a radian is. Okay, so we're going to take these 75 degree angles, 160 degree angles, negative whatever degree angles, and we're going to transform them to what we call a radian measure. It's kind of like a different unit of measurement. Like we have centimeters and we have inches, okay? So a radian is also a unit of an angle instead of in degrees, but it's based on length, based on arc length. I don't know if you remember from geometry, but in geometry you learned about the length around the circle. It's called our circumference, right? Okay, if I go all the way around the circle, that's called our circumference. And then arc length was just a piece of the circumference. Okay, and so radians is measured in the length of the piece of the circumference. Okay, 1 radian is going to be defined as the measurement of the angle formed when the radius is equivalent to the length of the intercepted arc. I know that makes no sense to you. Okay, so we're going to recall that the circumference of a circle is 2 pi r. Okay, right? Circumference equals 2 pi r. So what if we said our radius is 1 unit? We're going to say our radius is 1 unit, okay? And we will look a lot at this with radius equal to 1 unit, especially next section, because that's what we call our unit circle. So if our radius is 1 unit, okay, then 1 full revolution around the circle, okay, 1 full revolution of 2 pi r is going to be 2 times pi times 1, which is 2 pi, okay? So a full 360 degrees around the circle is going to be 2 pi radians. Okay. And we can use 1 as a radius because it really doesn't matter. The proportions of all this won't matter. Like if you have a radius of 4 or a radius of 8 or whatever, it ends up all being the same proportion-wise, okay? So we can say the radius is 1 unit. So a full 360 degrees, which is 1 revolution, is going to be what we call 2 pi radians. That's the length. So if I look at 180 degrees, which is half of the circle, okay, I'm going to get half of the amount of the radians. So half of 2, we're going to get 1 pi radians. So 180 degrees is pi radians because I can take half of 2 pi for half of a circle. So we get pi radians. Now, you'll notice I put this word radians here. We don't have to write that out, okay? When we see the pi in our angle measurement, we know that is radian measures, okay? So there's no real symbol for radians. It's just when we see the pi in there, we know that it's radian measures, okay? So converting our degrees to radians or radians to degrees, we're going to look at how we can do this, okay? Because sometimes we're going to be in degree measure and we're going to want to change it to radians, or sometimes we'll be in radians and it'll be easier for us to be in degrees. So if you are going from a degree to a radian, what we're going to do is we're going to multiply, we are going to multiply the degree times pi divided by 180, okay? So this is going to change it to a radian measure. So if I have 30 degrees, I'm going to take my 30 degrees and I'm going to multiply it times pi divided by 180. Okay, and then I'm going to reduce my fraction. Some of you guys have calculators that you can reduce 30 over 180 and it'll tell you what the fraction is. If you don't, you just have to do this by hand. I know that 30 goes into 180 6 times. Okay, and so what I'm left with on the top is a pi, and then on the bottom is 6. And so 30 degrees is equal to pi over 6 radians. You've just changed that 30 degrees to a length of pi over 6 radians. That's the arc length for a 30-degree angle, pi over 6. And because the pi is in there, we know that is the radian value. Okay? Let's try another one, 150 degrees. So I'm going to take my 150 and I'm going to multiply it times pi divided by 180. Again, degrees to radians, I multiply by pi over 180. And I'm just going to reduce as much as I can. 150 and 180, I can reduce this one by 30 and this bottom one by 30. And we would get a 5 pi on top and then a 6 on the bottom, okay? So if I reduce the top and bottom by 30, I get 5 pi over 6, and this is my radian measure for 150 degrees. You need to make sure you reduce your fraction all the way. So if you didn't realize 30 goes into both, maybe you realize 10 goes into both, and you do 15 over 18, and then you keep going from there, and eventually you'll get to 5 over 6. Don't forget the pi though. 5 pi over 6, okay? The pi tells us that's the radian measure. And then this last one here, this negative 220, okay? Take that negative 220, we multiply it by pi divided by 180, okay? We can reduce this as well. I believe it reduces by 20, top and bottom, so I can reduce by 20 here and 20 here. And what I have on the top is I have negative 11 pi. Make sure you don't lose that negative, divided by 9. Okay? And again, maybe you didn't notice that it divided by 20 top and bottom. Maybe you noticed it divides by 10 or whatever. And you just keep going until you have a completely reduced fraction. Make sure you keep the negative. Okay? It just means it's going in a different direction. All right? And that's a negative 11 pi over 9. So that's going from degrees to radians. Now, if I want to convert from radians to degrees, I'm going to take the radian, and I'm going to multiply it times 180 divided by pi. Okay? And what will happen here is every single time that pi will cancel. And then you'll end up with your degrees, okay? So, I have a radian. I know it's a radian right here, 4 pi over 3, because it has that pi value in it. So, I'm going to take 4 pi over 3, and I'm going to multiply it times 180 divided by pi, okay? So, what always happens in this case is the pi's will go away, because you're going back to degrees. There's no pi in it, okay? And then it's about reducing as much as you can. You may multiply and then reduce, or you may cross-cancel and reduce. It's kind of up to you, whatever you'd like to do. So I like to reduce beforehand so my numbers are smaller. So I see that 3 goes into 180 60 times, and on the top I'm left with 4 times 60. 4 times 60 is going to be 240 degrees. Notice I no longer have a pi there because it's now in degree measure. So if you have a pi left over, you've multiplied by the wrong thing. Okay? So you'll notice the difference between the two. On the top one, I multiplied by pi divided by 180. I still have a pi in my answer. In my bottom one, I multiply by 180 over pi, and that clears the pi's out. Okay? Going on to number 8, negative 5 pi divided by 36, negative 5 pi over 36, and I will multiply by 180 over pi. Okay, and just as I said, these pi's will always cancel, and then you can reduce as much as you can. Oh, I put 360, not 36, my bad, sorry. These pi's will always cancel, and then reduce as much as you can. Again, you can multiply negative 5 times 180 and then divide it by 36 in your calculator, okay? Or you can say, okay, I know that 36 goes into 185 times, and then negative 5 times 5 is a negative 25 degrees. And there you have your degree measure. Okay. And then last one we will do here. So I'm going to take my 7 pi over 4, and I multiply it times 180 over pi, and I know those pi's cancel. Pi divided by pi goes away, and I also know that 4 goes into 180 45 times, and then I have on the top 7 times 45, and so we get 315 degrees. They should always reduce to a whole number. Okay? And that is converting from degrees to radians and radians to degrees. You might have to do this, I would say more so in radians, changing it to degrees, because sometimes when we figure out like a sine, cos, or tan of these specific angles, it's easier in the degree measurement for some people. So you might have to convert in that way. Okay, so that's a radian. Again, a radian is just the arc length. Okay, instead of saying it in degrees, we're talking about length, and that's the radian length. When you have the pi in it, that is your radian measure. Okay, if there's no pi, then you can be sure it's a degree. But usually the degree will have, you'll see the little symbol with the circle in it. Okay. All right, so now we're going to look at what we call coterminal angles. So we had standard angles, okay? These are standard position angles right here, okay? We had what we called, oh, we didn't talk about that. Just kidding. That'll be the next part. And then we had angles that we converted to radian measures. And now we're going to look at something called coterminal angles, okay? Angles that are in standard position with the same terminal side are called coterminal angles, okay? Give two coterminal angles for a given angle, one positive and one negative. This is an example of, I said this right here, is this 430 degree angle. This 430 degree angle also is the same angle as this 70 degree angle, okay? We said we went one full revolution and then we went another 70 degrees. And what happened is 430 degrees and 70 degrees ended at the same exact place. And so that's why they are coterminal angles, okay? And so we can find coterminal angles by adding or subtracting 360 degrees. So we make a full revolution and then that angle, okay? And so what happens is those angles are called coterminal angles. So if I have 65 degrees here, and I add that to 360 degrees, I have an angle that's 425 degrees. Okay? If I add another 360 and get to 785 degrees, it's still an angle at 65 degrees. No matter how many revolutions I do, I would still be at 65 degrees. So 65 degrees we'll say is like right here. This is 65 degrees. Okay? If I do a full revolution, 360 plus another, plus another 65 degrees to get to 425, you'll notice I still end at the same exact place. That is called a coterminal angle. So 65 degrees and 425 degrees are called coterminal angles. Now the same thing happens in the negative direction. If I take 65 and I subtract 360, I get a negative 295 degrees. So if I work backwards, okay, and I go negative 295 degrees, I will still end at that same spot of that 65 degree angle. So negative 295 and 65 degrees are called coterminal angles. Okay, there are an infinite amount of coterminal angles. This is just one revolution in the positive direction and one revolution in the negative direction. But I could go 10 revolutions, 3,600 degrees, plus 65, 3,665 degrees is the same exact angle as 65 degrees, okay? So they are called coterminal because of these extra revolutions. We end up at the same place, okay? This next one, 540 degrees, okay? It's already made one revolution, so let me subtract my 360 degrees and I get 180 degrees, okay? And so you have 540 and 180 is 360, or excuse me, 540 and minus the 360 is 180 degrees, okay? Now this one's a little bit different. I'm going to now take this positive 180 because that's the same exact angle, and I'm going to subtract 360 from it, and I will get a negative 180. And so there's my positive and a negative coterminal angle. I'm not too worried about this pink one. I just want you to realize that 540, that's one full revolution plus another 180 degrees. And so we end up at that 180, okay? And that's the important part of the coterminal. Now with radian measures, okay, one full revolution is going to be 2 pi. So if I add 2 pi to this, I'm adding 360 degrees, okay? So with 2 pi, of course, you have to get common denominators. So 13 pi over 18, if I'm going to add 2 pi, I'm going to add 36 pi over 18 for a common denominator. Okay, 36 over 18 is 2 pi. And so then you can add the numerators. 36 and 13 is going to be 49 pi over 18. And so this is a positive coterminal angle. Okay, we made a full revolution, and then we added that 13 pi over 8. And then I can do the same thing with the negative. I can take 13 pi over 18, and I can subtract 2 pi. I can subtract 360 degrees. Okay, so remember 2 pi radians was the same as 360 degrees. So if I subtract 2 pi, that's 13 pi over 18 minus the same denominator as 36 pi over 18. And so 13 minus 36 pi is going to be a negative 23 pi over 18. And so again, we are done. We have a positive coterminal angle and we have a negative coterminal angle by adding 360 and subtracting 360. Okay. And this last one, I'll just do it really quick. Same idea. I can add 2 pi. Okay, I'm adding 360. So that's 14 pi over 9. Plus, if I want to add with a common denominator, I'm going to add 18 pi over 9. Okay, so I multiply by 9 over 9 to get a common denominator, and that's 32 pi. 32 pi over 9. Okay, there's your positive coterminal angle, and then my negative coterminal angle. I can take 14 pi over 9, and I can subtract 2 pi. Subtract the 360 degrees. I know that 2 pi is 18 pi over 9, so it's 14 minus 18, and that's a negative 4 pi over 9. By the way, with these pi's, it's just like terms with x's. I can add 2x and 3x and get 5x. I can add 2 pi and 3 pi and get 5 pi's. Those are like terms with the pi's. But there's your positive coterminal and your negative coterminal. Okay, you add 360, you subtract 360. Okay. And so sometimes you're going to come across those, and it's important to know what the coterminal angle is. More so in the sense right here, like 540 degrees, realizing that's one full revolution plus another 180 degrees. So if you realize you're back at this 180 degrees, you'll know what to find for whatever the situation is. Okay? All right. This brings us to reference angles, okay? Reference angles are going to be super important, okay? It is going to be the positive acute. Remember, acute is less than 90 degrees, okay? Acute is going to be less than 90 degrees, anything between 0 and 90. Positive acute angle formed by the terminal side and the x-axis. Sketch and find the reference angles for each of these angles. So let's talk about what a reference angle is. All right. Let's say my angle here is 120 degrees. Okay, so we start here from our initial side and we go 120 degrees, and this is our terminal side to make 120 degrees. Okay. Every angle is going to have an acute angle. See, 120 is obtuse, it's not acute. Okay, that's formed with the x-axis. The reference angle will always come from this x-axis, always. Okay, so I want to know the acute angle formed with the x-axis for this 120 degrees. So I see that I'm on this left side or in the second quadrant. So it's going to be making an angle with this piece of the x-axis. And I want to know, what is this angle? This one is my reference angle here. Okay? It's what the acute angle is that forms with the x-axis. All right? And you have to figure that out using the fact that we know we start at 0 degrees, or we could say it's 360, okay? This is 90 degrees up to the first quadrant. This is 180 degrees, and then this is 270 degrees. So in this second quadrant, we're at 120, right? And I'm trying to get to this 180 degrees. Well, 180 minus 120 is going to be 60 degrees. This reference angle here is 60 degrees. And it's going to be very important when we get to our unit circle, because if you can, when we do the unit circle, we're going to be memorizing certain values. If you can memorize the first quadrant, you have all of the other quadrants taken care of because of these reference angles, okay? So a reference angle, again, only with the x-axis, okay? A lot of people want to do it with this y-axis right here. They want to make an angle with this y-axis, and it's never going to happen with that y-axis. It's always with the x, okay? And it's that acute angle, that very small angle with the x-axis, okay? So let's do some examples of these. They're very important. 225 degrees. All right, let's look at the angle 225 degrees in standard position. So I'm going to start, oops, that's not what I wanted. I'm going to start here, okay? And I go 225 degrees. So I go 90, 180, and 225 is going to be right about there, between 180 and 270, okay? And so this is my 225 degree angle. Now, I want to know what the reference angle is, okay? My reference angle is always going to come from the x-axis, okay? And so my reference angle is going to be this angle right in here. Let me actually do a different color, okay? That is formed with the x-axis closest to it. Well, this x-axis is at the 180 degrees, okay? If this whole thing goes to 225 degrees, I can say, okay, 225 minus 180, and I get 45 degrees. This little piece after the after the 180 is 45. And this is my reference angle, 45 degrees. Let's try it again. Negative 310 degrees, okay? Start here, negative 310, negative 90, negative 180, negative 270, negative 310 is going to be somewhere about here, okay? This is negative 310. My reference angle needs to come from my x-axis. So it's going to come from this side because I'm on the right side. So if I'm on the right side, I go from the right side of the x-axis. If I'm on the left side, I go to the left side of the x-axis. And so my reference angle is going to be this angle right here. This is going to be my reference angle. It's making the angle with the x-axis. So I need to find this measurement here. What is this measurement? Okay. So because I'm at almost to 360 degrees, let me take 360 minus 310, okay, and we get 50 degrees. That is my reference angle. Reference angles are always positive, by the way. Positive acute angles, okay? Because remember negative 310, if I add 360 to it, I get a positive 50 degrees, okay? That's the coterminal part of it. And so my reference angle here is 50 degrees. Okay. Now, radians. We haven't talked much about this, but we said this right here, we start at 0 degrees or 360 degrees, 90 degrees, 180 degrees, and then 270 degrees, okay? We haven't converted this to radians yet. All right, radians. 0 radians or 2 pi radians. We know that 360 degrees is 2 pi. 180 degrees we know is pi because it's half of the 2 pi, right? 360 degrees is 2 pi, so half of that was pi, okay? At 90 degrees, we get pi over 2 radians, half of the 180, okay? And then at 270 degrees, we get 3 pi over 2 radians, okay? So, actually, let's go back up to the very, very top of the page, okay? Right up here. And let's put those values in. 0 degrees or 360 degrees is going to be 0 radians or 2 pi radians. 90 degrees is going to be pi over 2 radians. 180 degrees will be pi radians. And 270 degrees will be 3 pi over 2 radians. Okay, so you need to know not only where the degrees are, but where the radians are. Let's write those in. Okay. Okay. So going back to my reference angle, let's figure out where 2 pi over 3 is. Okay. 2 pi over 3 is going to be less than 1 whole pi, and it's going to be more than half of a pi. Pi over 2 is half of a pi. So I'm going to be starting here. Okay. And so I'm going to be more than half of a pi, but I'm going to be less than 1 pi. So I'm going to be about here for 2 pi over 3 radians. Okay? This is going to be 2 pi over 3. Okay? Notice there's no degree symbol because it's an arc length. Okay? 2 pi over 3 radians. Now, my reference angle. My reference angle has to come from the x-axis because I'm on the left side. I'll be using the left side of the x-axis. And I need to find the angle formed with this axis. So basically, I'm going to be finding this angle here. This is going to be my reference angle. So instead of 180 degrees, I'm going to be taking pi minus 2 pi over 3 to figure out what that missing angle is. So pi, if I've got common denominator, is 3 pi over 3 minus 2 pi over 3, and we get 1 pi over 3. So this angle here, my reference angle, is pi over 3. Okay. So again, reference angles are the angles created by the x-axis and only the x-axis. Okay? It's kind of like what's left over, what's needed to get to either the 0 degrees or the 180 degrees. Always. Okay? By the way, I know you guys are unfamiliar with radians and you're just getting used to them. Okay? If you wanted to, you could convert 2 pi over 3 to a degree by multiplying by 180 over pi. It would be 120 degrees. And then you could say, oh, okay, 120 degrees. That means I have 60 degrees left for my reference angle. And then you could take the 60 degrees and convert it back to radians. I don't know. So it seems like a little bit more work. So you might have to deal with the fractions. Okay. So this is where your reference angles are going to be important. Okay. We are going to look at points, and we are going to find the trig values of those points. So let theta be an angle in standard form and the point xy. Be a point on a terminal side of the angle theta. The distance from P to the origin can be found using this formula, and it's going to be Pythagorean theorem. So let's look here. We have an angle theta, okay? That's our angle. And this angle goes to this point P. So we create this angle here, okay? Angle, let's say it's 120 degrees, doesn't matter. And it ends at this point P with the point XY, okay? We can find the length of this point from the origin by doing Pythagorean theorem. It's actually a version of a distance formula, right? Okay, it all comes from the Pythagorean theorem. So if this point here is xy, okay, I can go out x, and I can go up y, okay, and I get to the point xy, right? And then if I want to find this length of this radius here, I can use Pythagorean theorem. And so what I can do is say, okay, x squared plus y squared is equal to r squared. And we can find the length of r, okay? Now, in order to find the sine of this angle, what we can do is use this reference angle right here, this reference angle, the one created with the x-axis, okay? And I can do SOHCAHTOA, okay? Oops. So the sine of this reference angle here, the sine is going to be the opposite y. Okay, so this will be the opposite from my reference angle. This will be the adjacent, and then r will be the hypotenuse. Okay, my reference angle will be y, and my hypotenuse will be r. And so in this case, the sine is always going to be y divided by r, y divided by the radius. So given a point, and you find the length of the radius, okay, you can say the sine of that angle is going to be y over r. And this is going to be very important because next section we do the unit circle. And in the unit circle, the radius will be 1, and so your sine is just going to be whatever the y value is. That's it, okay? But right now, we are not in a unit circle. We have a whatever point, and it creates a specific radius, okay? So keep going. If we do the cosine, cosine is adjacent over hypotenuse. Again, from our reference angle, we can use these reference angles for sine, cos, and tan. Adjacent is x, hypotenuse is r. So I'm going to come over here. Cosine is going to be x over r. And then the tangent, opposite over adjacent. The opposite is y, the adjacent is x from our reference angle. And so we get opposite y over adjacent x, okay? You're going to want to memorize these. The sine will always be the value of y over r. The cosine will always be the value of x over r. And the tangent is y over x. We're no longer in a random triangle. We are in a triangle on a coordinate system. We have a point x and y, and we're creating a triangle with the x-axis, okay? Cosecant, secant, and cotangent, these are the reciprocals. So cosecant's the reciprocal of sine, and so we just get r over y. Secant is the reciprocal of cosine, so we get r over x. And cotangent, reciprocal of tan, so we get x over y. Okay. So let's put this into an example. We have the point 5, negative 2. It's a point on the terminal side of angle theta in standard form. We are going to find the exact values of the trig functions for theta. Oops. So, oh, geez, Louise. If I'm going to come over here, let's put the point 5, negative 2 on our coordinate system here. So I'm going to draw in 5, negative 2. 1, 2, 3, 4, 5. And then 1, 2. That's going to be this point right here. This is going to be the point 5, negative 2. Okay? And if I'm drawing an angle, we start at the x-axis. Some angle theta is going to end at 5, negative 2. Okay? Right here. Okay? This is our angle at 5, negative 2. Okay? Now, because of reference angles that come from the x-axis, I can call this angle my reference angle theta, and I can create a triangle to the point 5, negative 2 from my x-axis. It's always from the x-axis. So if it's on the right side, you'll go the positive x-axis. If your angle's on the left side, you'll do the negative x-axis. And because we went out 5 on the x, this length here will be 5. And then we went down negative 2 on the y, so this length here will be negative 2. Okay? We want to keep those negatives in there. Okay? And then we can find our radius r here by doing Pythagorean theorem. So I can go over here and I'll just do a little work. 5 squared plus a negative 2 squared is going to equal r squared. Okay, so 5 squared is 25. Negative 2 squared is going to be positive 4. This will always be positive when you square it. Always, always. Negative 2 times negative 2 is positive 4. And that equals r squared. So that's 29 is equal to r squared. And when I square root both sides, I get root 29 is equal to r. If you could simplify root 29, you would. We can't in this case, so we won't. Okay? So, for what we have here is we said x was 5, y was negative 2, And then our radius r is the square root of 29. And knowing all of this information, I don't even need to look at the triangle anymore because I know that sine is opposite over hypotenuse, which is y over r. Okay, so we have y over r here, which is -2 over root 29. Now, I said you had to rationalize denominators. I will actually accept your answer as -2 over root 29. This is fine. I will take this answer, okay? You might also see an answer like this, though, just an FYI. I can rationalize root 29, top and bottom, and I will get -2 root 29 over 29. I will also accept this answer. And I think if it was a multiple choice test, I probably will put both answers so you'll see both. And if it's not a multiple choice test, if it's a free response, I will also accept both answers. Okay. So again, using these new definitions, okay, of trig functions, angles, and standard forms, and using our reference angles, we can always say that for a point xy, we have sine as y over the radius. And now cosine is going to be x over the radius. So I can do x over r, and that's going to be 5 over root 29. Again, I will accept this answer. You can also rationalize it. Some people are really good at this and see it right away. And so if I rationalize, I get 5 root 29 over 29, and I'll accept this answer as well. Okay, either answer I'm okay with. And then the last one we said was in this definition, y over x. And so y was a -2 and x was +5, and so your tangent of theta for this point, 5 -2, is -2/5. Notice we don't even know what the angle is, we just have a point, okay? But we know what that ratio of the triangle is. All right, now the cosecant, secant, and cotangent, and then we'll be done. Remember, these are reciprocals of the sine, cos, and tan. I would do the reciprocal here and not this one because I don't want to have to rationalize it again. Oopsies. Okay. So if I take the reciprocal of the original, I get root 29 over -2. You can put that negative on the top, on the bottom, in the middle. It doesn't matter, but that's all we need to do. Okay. I will take the reciprocal here, root 29 on the top over 5. And then the reciprocal of -2/5, a -5/2. And we are done. That was probably a little tough. Do your best on the homework, okay? And if you've made it through this far, good job. And if you write on your homework at the top of the page, so I know that you listened to this entire thing, Mrs. McCann rocks, or Mrs. McCann is the best, or something very nice about me, I will give you a point extra credit on your homework today. Okay, so if you made it through this entire lesson, good job. And if you write something nice at the top, I will give you 1 point extra credit on your homework. Good job, everyone. Do the best you can and come to my office hours if you have any questions.